All right, for this video, we are talking domain and range. So basics of domain and range, the easiest way to see it, in my opinion, is from a graph, right? So if I had, let's give ourselves an absolute value function, and let's flip it over and make it set up like this. We'll give our coordinates of this point. Let's say it's the point 4, 3. It's arbitrary, but we're just trying to make sense of things. What the domain represents, all x, so it's all basically, I'm going to use quotes here, legal x values for the function. So what does that mean? What x is our input to this function. What numbers could I plug in to an absolute value function? I could plug in positive, negative, I could plug in 0. For this particular problem, our domain is infinite. It would go from negative infinity to positive infinity, right? This answer here is telling us the possible x values for this function are any values that are greater than negative infinity and less than positive infinity, right? That's what we're talking about with domain. With range, we are looking for all reachable y values. And what I mean by reachable is that not all y values on this graph are represented. If I were to shade in what y values, where our graph exists, it exists down here, and it keeps going up and up and up, and then it stops at that vertex. So what reachable y values do we have? What's our range here? For all values where y is less than or equal to 3. Why is it 3? The y coordinate, let me get a different color there. The y coordinate of that vertex tells us that it's 3. Why is it less than or equal to? Well, the fact that our arrows point downward tells me that all my values are going to be less than that vertex value. So that's the idea with a graph, but then we see something like this in number 12. What is the domain and range for the function that we see here? So the extra step is that we don't have a graph. Now, if this is a calculator problem on a test day, I would graph this and use the graph to identify the domain and range. That is my best bet. If I don't have a calculator, mentally at least, I'm thinking in terms of transformation. Our parent function here is the quadratic parabola, and we have a few transformations. We can move to the right 2, down 1, so our vertex is now at the point 1, negative 2. We also have a vertical stretch by a factor of 2, and so our graph's going to look something like this. That blue graph is the one we are curious about. With a quadratic, our domain here is going to be infinite because there is no value I can't square. Our range depends on the vertex in this case. In this case, we know that range always depends on y and that it depends on the vertex for a quadratic. So we're going to plug in negative 2. Then we have to pay attention, does this graph open up or down? It opens up, so we're going to say greater than or equal to. So when we approach a domain and range problem, it's really a combination, right? Do I understand how quadratics work? And how do I understand how transformations work? So either we want to be able to quickly sketch a graph to use that and for domain and range, or if we have our calculator, we can plug in and use that graph to find the values that are legal and reachable for our domain and range.